Hi guys. All right, last section in chapter 10. We're going to be looking at some of the graphical connections between the algebra and quadratics. So let's talk about, we're always dealing with quadratics in this whole chapter, so probably sick of quadratics by now, aren't you? You're going to get hit really hard with quadratics in college algebra again, right? Yep. Okay, everything is the same, it's just more in depth. You go a lot deeper into these subjects, so it's really nice to have this class to see just the basics and a real skimming of all the topics, so that when you do get to college algebra and you get real deep within the topic, you've got this foundation to build upon. I've been teaching college algebra for a long time, and I'm trying to hit the high points for you guys so that you really have a solid base to go back to, so you know what's going on. And what's really helpful is to learn this calculator, because you have to have one for college algebra, and that is not the time that you want to learn it. You want to learn it now and then use it so that that part of it's clear. All right, so quadratics, what do we got here? We've got some sort of parabolic shape, right? Okay, so the highest or the lowest point, depending on which way it's been flipped, is called the vertex. Okay, it doesn't have to sit on the axis. So the vertex is either the highest or the lowest spot, depending. Well, let's talk about what makes it flip like that. All right, that's A. That's the value of A. So if A is bigger than 0, so if it's a positive value, obviously it can't be 0, otherwise you've wiped out your x squared term, and then it's linear. But if it's bigger than 0, then you're going to have something that looks right side up. And if it's less than 0, it's going to be upside down. So that's very important, okay? Now we have two different types of forms for quadratics. All right, we have the standard form, which we've already seen, ax squared plus bx plus c. All right, and in order to find the vertex when it's in this form, we find the x-coordinate of the vertex. Okay, so this is to find the vertex. You have to find the x-coordinate first, and that is minus b over 2a. Okay? And the y-coordinate is f of minus b over 2a. What does that mean? That means, let's say my vertex here was 2 for the x-coordinate. Then I would plug a 2 back in here. I would evaluate the function at 2 to find my y-coordinate. Okay? So we're going to do the standard form first. Okay, so we have f of x is equal to x squared minus 1, which we can also write as x squared plus 0x minus 1, right, if we wanted to. So here we have a is equal to 1, b is equal to 0, and c is equal to negative 1. Remember, it's x squared, x, no x. Okay? So my x-coordinate is equal to the opposite sign of b. Well, b is 0. Okay? So 0 divided by anything, I don't even have to complete the bottom. What is 0 divided by anything? It's 0. Right? So my x-coordinate on this thing is 0 for my vertex. All right, as soon as my numerator is 0, then the whole thing's 0. To find my y-coordinate, I'm going to evaluate the function, this function here, so I'm going to write it again, f of x is equal to x squared minus 1. I'm going to evaluate it at 0. Well, that means to put a 0 in wherever you see an x. 0 squared is 0, minus 1 is minus 1. So there's your vertex, 0 and minus 1. Should we check that with the calculator? Yeah, I think we should. All right, x squared minus 1. Let's first of all take a look at the graph. All right, does that look like it's at 0, negative 1? Well, it sure does to me. Let's verify that. All right, so we're going to calculate it out. We're going to calculate out the minimum value, right? That's a number 3. It's asking me to be on the left side of this point. I'm kind of on the point right now, so I'll just go to the left a little bit, just with one click like that. And then it's asking me to be on the right side of that point, so I'm going to use this button here just to kind of scooch over. And then it says, you want me to guess? And I say yes by hitting enter. All right, now this right here is so small, negative 2.051 times 10 to the negative 6th. The calculator is doing that because it's a guess, for one. This is equal to 0.0000, well, negative obviously, 1, 2, 3, 4, 5. This is as close to 0, this is approximately 0. It's so close to 0 that we're just going to call it 0, okay? So this is the way the calculator is saying 0 and negative 1. Okay, so if you get one of these E's with this the scientific notation, and it's a big number in there, then it's just basically 0. All right, so that one's correct. So we're going to type in an ordered pair here. Vertexes are always ordered pairs. Okay? Now the second type of form that we have, okay, so far what I've seen is the standard form, and this is how you find it, the x-coordinate and the y-coordinate. The next type of form that we have is called the vertex form, and this is different. And your quadratics can come in either one, okay? So your vertex form is this, okay? And you can always identify it by these sets of parentheses here. You can see from this one there's no parentheses in there. I mean, look at this. That's vertex form. That is standard form. So you can kind of see. All right. So if that is in vertex form, my vertex here is HK. Okay, it's whatever this is and whatever that is. That makes it really easy. So if I have f of x is equal to, and I'm going to try to match this, okay? My a on my problem up in here, I don't have a number in front. So that's going to be a 1. Not that that matters. Then I have x minus 2 squared, and then I'm adding 0, right? Because I don't have anything past here. So if I were to insert things in there so it matched it exactly, I could really see what my vertex is. My vertex, therefore, is going to be 2. It's not a negative 2, it's a positive 2. This has a subtraction in it. So therefore, h is always opposite of what it looks like, and k is always what it is, what it looks like. So my vertex here is 2, 0. Okay? This has a subtraction, so it says x minus whatever h is. H is 2. Okay, so this vertex is 2, 0. So we're going to put that in there. Some of you are doubting me. Let's try to find, good. There's one with a plus. All right. Again, I'm going to try to match this. Okay, I'm going to write it again just so I don't have it hanging there. Okay, so I've got that as my standard. Okay, what's my a? My a, again, I have nothing in front, so that's got to be a 1. X minus h. Well, I've got a plus 1, but I can always write down minus a negative. Isn't that adding? Now it looks like the original vertex form. And I've got plus a negative 2 if I wanted to be really precise here. Therefore, my h is negative 1 and my k is negative 2. X minus whatever h is plus k. So here my vertex is minus 1 minus 2. Just see how h is always opposite of what it looks like. It kind of looks like it's a positive 1, so it's a negative 1 here. K looks like a negative 2, so it is a negative 2. And that was the opposite for this one. This one kind of looked like a negative 2, so it's a positive 2. This one was a positive 0 or plus 0 or however you want to look at it. So it is what it is. Okay, so whenever we have the h, it kind of appears to be backwards of what you think it looks like. But that's only because there's a subtraction in the formula. Okay? Now we're supposed to pick the correct graph. Well, what is this telling me? I'm not going to even graph this thing. I'm not going to use this calculator because this stuff is so easy that we don't even need it. What is this telling me? This is telling me that my vertex sits at -1, -2. That means it's going to be either the lowest or highest point. Well, let's go back up here and determine whether it's going to be the lowest or the highest point. What did I say my A was? I said it was a 1, and it's a positive 1. So that means my graph looks like this because it's bigger than 0. Okay? So now I can just completely disregard B. It's flipped the wrong way. So now I'm up to A, C, or D. Well, now I'm going to start to look for the vertex that sits at -1, -2. -1, -2 is not there. It's not there. It's probably this one. Let's just blow it up a little bit. These are -10, so these are going by 2's. So 2, 4, 6, 8, 10, right? So -1, -2, there's the vertex. I don't even need my calculator, okay? Good job. All right. So, for this quadratic function, tell whether the graph opens upward or downward and whether it is wider, narrower, or the same as f of x equals x squared. Well, we're going to have to do some playing around here. So, my standard quadratic is x squared. All right? Let's take a look what that looks like. There's my standard quadratic. The vertex sits at 0, 0. It's this wide. Okay, so we're always comparing it to the standard quadratic of x squared. I'm going to keep that in there, but I'm going to graph another one that has a negative on it, and we're going to see indeed that it does flip. Okay, so I'm going to just do a -1 x squared. Okay, remember I said if A is positive, it's going to be right side up, and if A is negative, it should flip upside down. So it's going to leave that one in there, and then it's going to graph the second one underneath it. Do you see how that one flipped it? So that does indeed work. All right, so I'm going to get rid of that one. What's going to happen if I put a 5 in front for A? What do you think is going to happen to the graph? Well, let's take a look. There's the standard, and there's the second one. They always graph in order. It made it narrower, didn't it? So there's another rule that we have. Okay, so our first rule is that if A is bigger than 0, it goes upward. If A is less than 0, it'll point downward. Okay, we just saw that. Now, if A is bigger than 1, such as 5 or 25, okay, these are all numbers that are bigger than 1, look what's happening to this graph. It gets narrower and narrower and narrower as we go on. So A bigger than 1 narrows the graph, so it gets skinnier, okay? Well, let's see if we put in something that's underneath 1, if it's between 0 and 1. So let's put in 0.5 x squared. Let's see what happens then. Here's your original. There's your new one. So if A sits between 0 and 1, then it widens. Okay? And that's the absolute value because we're taking into consideration the negative up in here with the downward flip. All right? So there's your rules. So again, we don't even need the calculator to answer these questions. Well, we have to see our rules though, don't we? Here, you know what I'll do is I'll slide that down here and then I'll get that one down. Okay. No, I gotta get that down. Just, there we go. Okay, so let's take a look at what's going on here. A is a -0.4. A is negative. That means it's flipped downward. So that's our first part. It's going to open downward, okay, because a is negative. And a is always the number that sits in front of the x squared term. And now we're saying, because it's a 0.4, what's that going to do to it? Well, 0.4 is between 0 and 1, so it's going to widen it, right? So here's my choices. It's either wider, the same, or narrower. Well, it's got to be wider. Okay? And then we can use the calculator. If we don't trust ourselves for some reason, we can always put this in here. We got negative 0.4 x squared. We can always do that, but we don't really need to do that at this point. It's been flipped upside down and it's wider. Okay? So let's try another one. What is your a term? Your a term is a 9. It's a positive 9, so that means it's opening upwards. Okay? Your a term is bigger than 1, so it's going to narrow it, right? Make it narrow because 9 is bigger than 1. Okay? All right. Choose the correct graph. Well, does this one even an option? This has a power of 2, which means it's quadratic, which means it's parabolic, which means it's not linear. So they're just going to throw that one at you, so don't pick the linear one, obviously. All right, it's got to be flipped right side up because a is 1. Okay, so that's good. All 3 of these are flipped right side up, right? Well, where is it on this graph? Well, I need to find the vertex, don't I? I want to know where it's shifted. So I can find the vertex through the minus b over 2a, f of minus b over 2a, because this is in standard form, or I can take a look at the picture through here. Sometimes that works, sometimes it doesn't. It just depends on the problem. Sometimes they're so close you can't tell them apart. You have to actually do the vertex. There's my picture. Okay? My vertex sits way down here, so that's got to be this one. This one's too high, and that one's sitting on the x-axis. It's got to dip below, so we'll say it's B. And we're going to verify that by doing the vertex form, right? Excuse me, finding the vertex through the minus b over 2a if we needed to. All right, what about this one? Is it linear? No, it's still not linear. It's still quadratic. Okay? This time I have a negative 1. That means it should be flipped upside down. So let's rely on the calculator again to put that in there. Minus x squared plus 5. I could also find the vertex through the minus b over 2a. And doesn't it look like that one? This one's below, this one's at, and this one's above the x-axis. Okay? Aren't you wishing that I put these on the test? Like, put 100 of these on the test, Simone, please. All right, so let's talk about what all these pieces and parts do. This is in vertex form. All right? This time, we're not even going to use the calculator because we don't need to. The vertex form tells us right away what's going on. First of all, what is my a value? Is it positive or is it negative? Well, it's a positive number. So could it be B or C? No, it can't because those are flipped upside down. Okay, I have a positive a, so it's got to either be A or D. All right. Now, both of those are wider than a normal. Supposedly, we don't know, but that's what this half is. And where is my vertex? Go back to this stuff. Isn't it 6, 0? Isn't H 6 and K 0? 6, 0, is it this one or is it that one? Well, it's got to be that one. Okay? We don't even need the calculator. I could take about 3 seconds to figure that one out just by looking at the graph, the value of this, whether it's positive or negative, and looking at the vertex, because the vertex just pops right out at me. I can do that way faster than I could ever get it in the calculator. I don't even need the calculator for a lot of these. All right. I'm not sure why it says to plot at least 2 points when you're just doing a multiple choice, so let's just ignore that. But again, we're not going to use our calculators, we're going to use our logic skills. Okay? A is positive, so they all have to be flipped upward, which they are. And 2 is between 0 and 1. No, it's not. 2 is between 1 and infinity, so it's bigger than 1. So it's going to be narrow. So these all look real narrow to me, which is good. And then I'm going to pick off my vertex. What do I have? 2, -6. Well, how easy is that? 2, -6 is probably this one, isn't it? 2, 2, 4, 6, -6. It's that one. Okay, so it's B. Just based on the fact that I've got the positive value here, so it has to be upright, and that my vertex sits at 2, -6. Oh, now it wants us to graph. All right. I don't think we've graphed any of these yet. Maybe we have. My mind is, I don't remember. But in any case, you can see that this is a parabola. Okay? This is your parabola tool here. And when I click on that, the first thing that it wants down here, you've always got the directions down here. It wants the vertex of the parabola. Well, this is in vertex form, right? So my vertex here is like this one. It's got that negative, negative. Okay, so let's just do x minus h squared plus k. Our function here, y equals, or f of x, we've got a -1/5 x plus 5 squared plus 3, right? If I want to match this exactly, then I'm going to want to do -1/5 x minus a -5, because subtracting a negative is the same as adding. Now I can see that my hk is a -5 and a 3. That's my vertex. So when this thing wants the vertex to begin with, we have to do -5. What was it? 3. -5, 3. -5, 3. All right, now what can we deduce from the equation? Well, I know it's got to be upside down because it's got a negative. A fifth is between 0 and 1, so it's got to be wide, right? So it's going to look something like this. You know, it's not going to look like this. It's going to look like that. Now it's telling me to plot any other point on my parabola. Well, how do I do that? Well, I can choose any point that I want and plug it in for x and calculate out my y, or I can use my calculator to plot this. 1 divided by 5. Let's just take a look at the picture first of all. And then we have x plus 5 squared plus 3. I mean, I could make a t-chart pretty easily. Does that look like -5, 3? Okay, wait. 1, 2, 3, 4, 5, 3. Yeah, that looks like it's the vertex there. So now we can go into the table. And we have to pick whole numbers in here. My MATLAB won't let me go between grid points. See how it jumps from grid point to grid point? So I have to have, I can't pick, let's say, -1, -0.2. So I'm going to have to pick this one, 0, -2. Those are both whole numbers. So that one will work. So 0, -2. Check my answer. Fantastic. Doesn't matter which one you pick on here, as long as it's on the graph. It's got to be between all your 10s because it's going from 10 to 10. There's another one, -5, 3. Is that one on there? Yep, that's my vertex. Those I could have used -10, -2. There's another whole numbered one. Okay. Or I could have just made a t-chart, right? And I could have found all my values like this by cranking out my numbers, but I don't want to do that right now. That's not the point of this exercise. All right, let's see what we got here. tell whether a linear or quadratic function would be more appropriate model for this set of graphed data. If linear, tell whether the slope should be positive or negative. If quadratic, tell whether the coefficient of x squared should be positive or negative. All right, let's go back into what linear is. Linear is a line. Quadratic is a parabola. So it's either this or this, that or that, right? So we're going to take a look at this data. Let's just blow this up. This is definitely not a straight line. This is following more of a curve, part of a parabola, isn't it? So to me, this would look more parabolic. It's more quadratic in nature than it is linear. Okay? Then you have to take a look at the way it's tipped. Is it tipped upward or downward? Well, it's tipped, for the piece that's there, it's tipped upward. So that means the coefficient of x squared should be positive, not negative, correct? Yes, correct. Let's take a look at this one. Well, that, if you connected the dots, that looks pretty linear, doesn't it? It really does. So this one's more linear if you graph the data. All right. What about my slope? Lines have slopes. Remember which way is which? Which one is which? This is downhill, so that's a negative slope. This is uphill, so that's a positive slope. I have more of a downhill thing, so it's going to be a negative slope. Okay? And, well, I feel like I'm beating a dead horse here. Okay, so here we have another line. So this is linear. And this time my slope is running uphill, so that should be a positive slope. Okay? All right, so we ended on a really easy, nice, light note, which I like. Sometimes when you get to the end of a chapter, you're fried, and that's usually where the hardest stuff sits. And then you kind of just go, oh my God, I gotta give up. So this one ended on a very light note here. And you're probably hoping that I put a lot of 10.6 in your test. So that's it for quadratics, and good luck on your test. And I will see you for chapter 11. That's the last chapter. So hang in there. You're doing great.